Everyone, this is Dave. I'm an engineer at OSO, and I'm just going to show off using OSO to add authorization to a simple GraphQL application. So today we'll be using Python for this, and we'll be using the SQLAlchemy ORM library to manage our data, and we'll use Graphene as our GraphQL server. All right, so I have here a simple application as a starting point. It doesn't have any authorization added. Let's just go ahead and take a quick look at what we have. So there's two models. This is just going to be an expense application as an example. So we have an expense. Maybe it's something someone bought, dinner, a desk. Expenses have an amount. They have a user who created them. And then they have a description. And the user model is really simple. It just has an email. Okay, so these are our models. We set them up using the Flask SQLAlchemy library, which just makes getting SQLAlchemy integrated with Flask pretty quick and easy. And then we're going to look at our GraphQL schema. So our GraphQL schema uses Graphene, and in particular, we're using the Graphene SQLAlchemy library, which lets us create schemas types that pretty much one-to-one replicate our models. So we have an expense GraphQL schema. This is for the expense model, and similarly, we have the same thing for a user. And that's really it. The app is pretty simple. If you go ahead and look in the top level file, we'll see that we have a single route. This is just a Flask app that we're using to expose GraphQL, and it's just the GraphQL endpoint. So we have the app running down here. Let's go ahead and check out the results we're getting. Before I do that, I just want to quickly put up this link. So if you want to clone this on GitHub and follow along, it's available here. You can go ahead and pause and get that clone down if you want to go step by step with me. Okay. So I'm going to be using the GraphQL query tool to issue GraphQL queries to my running app. So let's just run this query. And this is going to give us a list of the expenses. And we have a couple fields we've asked for: the ID field, the description of the expense, and the created by field. And you can see over here we're getting 4 expenses back. I've set up the fixture data for this, so I happen to know this is just all the data in our database. We see we have a couple different users: Alice, Jim, and Bob. And we're seeing expenses for all of them. So we're going to add authorization to the app, and in doing so, we want to make sure that the logged in user can only see their own expenses. Today, we're going to have Alice be our user, so every single query we make is using Alice as a user, and ultimately, we only want to see Alice's 2 expenses instead of these 4. So as a first step, let's just add OSO to the application. So OSO is an open source authorization engine. It lets you specify authorization rules declaratively using a policy language called Polar. It supports multiple languages, but today, like I said, we'll be doing it in Python. So in this Git repo, I actually have a commit for every little step of this tutorial. So I'm just going to go ahead and check out the next commit, and I'll walk you through the changes that we made to add OSO to the app. All right, so here you'll see I'm on this commit setup OSO add policy. If you're on GitHub, you can look at that commit now or check it out now if you'd like. Let's reload this file. Okay, so we'll see there was a couple changes. I'm just going to pull up the diff here. 1 second, sorry about that. That's not the diff I wanted. All right. So we're seeing over here, we've added some lines of code. The main ones to look at, everything above is just imports. The main ones to look at are here. So on line 32, I set up an OSO instance. This is the entry point to the OSO library, and it's pretty much what we'll use for most interactions with authorization. Then we call this register models function. This will make our SQLAlchemy models accessible from our authorization policy. So this will let us write rules about what the user can do when they're accessing SQLAlchemy objects. And then finally, we're going to load this policy file by calling the load file method on the OSO instance. And my policy file is called policy.polar. Okay, so that's all that's needed to add OSO into the Flask application. And I missed this step here. Right here, we're just storing OSO on the application. So we've added OSO. Now we want to actually use it. So let's go over to our models file. And we'll see a change here as well. So we replaced the Flask SQLAlchemy instance with an instance of the authorized SQLAlchemy class, which is provided by OSO in the SQLAlchemy OSO library. There's 3 required parameters for this class. One is a callable that gives us the OSO instance. So remember, we stored it in our application initialization on the app itself. The second is to get the user who will be authorized. So our app has some simple stand-in authentication that places the current user on this Flask request context object. So that's what we're doing here. And then finally, we just always use a read action. So every authorization request in OSO has a actor, an action, and a resource, and we just set our action to be read always. Okay, so that's all we need to do to add OSO to the app. Now let's go ahead and look at our policy. So right now our policy file is empty. And if I go ahead and open the GraphQL query interface again and rerun our query, we'll see that we don't get any results. So OSO is denied by default, and that's the reason that no objects are being returned. OSO is denying authorization for Alice to read every single object because we have no rules. So let's write our first rule. The entry point to a OSO policy is the allow rule, which I've specified here. Every line in the policy is a rule. And the first argument to our rule is the actor. So this is who is performing the request. Next argument is the action, so what the actor is doing. And then finally, the resource. And this is the most basic of allow rules we could write in our policy. It specifies these three parameters, action, actor, action, and resource, but it doesn't place any requirements on them. So I've used the underscore to indicate that I won't use them. And we'll see if we save the policy. I have my Flask app reloading when the policy changes. I rerun the query, and now I'm getting everything just like before. Okay, so now we're back to where we were when we started. We have OSO added to our app, but we're not really doing anything with it. So let's just take this a step further. So one thing we could do with OSO is specify types. So remember earlier we made our SQLAlchemy models available in the policy. We can write a specializer to make this rule, this allow rule, only apply to a certain type. So now we said allow any user to do any action on any expense. And this colon indicates the type of this variable or parameter. Okay, so I'm going to save this policy again, and I'll rerun my query. And now we see we're getting basically the same result, but the created by fields are empty. So there's no result for created by. And the reason for this is we now are missing a rule for the user resource. So what OSO is actually doing when we run a GraphQL query is it's authorizing each resource that is used in that query. So it's authorizing expenses, and it's authorizing the user, which is accessible at this created by field. And we'll see in our model definition the created by field has type user. So that's why that rule is missing. So let's add another user rule here. So we're just going to, I'll just copy this top one, and we're going to change this last type to user. And we'll save that. And now we see we're getting everything once again. So we've now written a policy that allows any user to do any action on any expense and on any user. Okay, let's get a little more specific. So remember we said we wanted to allow users to read their own expenses. So now we're going to add a body to our rule, which we do with the if keyword. And we want to actually access these variables, so I'm going to remove the underscore. And I'll rename this one to expense instead of resource, just because that's a little more descriptive. So now remember our policy that we're trying to write is checking that the expense is created by the user accessing it. So going back to our models, we see the expense as its created by field, so we'll just access that from the policy. And we want the current user who's being authorized to have created the expense. So we'll just compare this directly to the actor that's being authorized. Okay, I'm going to save that policy. I'm going to go ahead and rerun this query. And we'll see we have what we originally wanted. We are only getting expenses created by Alice. We don't see the expenses from Jim. We don't see the expenses from Bob. All right, so let's see what's actually going on here. We did a little bit of work to integrate OSO, but we didn't actually change any queries that were being issued or write any GraphQL middleware or customize our GraphQL resolvers. So how is OSO actually applying authorization to only show us expenses that were created by Alice? I have a view in the application that returns the SQL queries emitted for the most recent request. So let's just look at that now. So that's down here. If you're running this alongside me, you can use the SQL endpoint. I'm just going to reload this. And now we're seeing the SQL issued in order to resolve this GraphQL query. So Graphene will actually make two different queries. One is to obtain the count. The second is to actually obtain the data. So let's just look at the second one. And we'll see there's a where clause here. This where clause is constraining the expenses returned so that we only receive expenses where the created by ID is 1, which is the ID of the current user who's logged in, Alice. And that's why we don't get the other objects. So our policy is actually translated directly from this declarative set of rules into our SQL query as an enforcement mechanism. And we can even use some other features of Polar, like writing our own custom rules, which let us represent concepts like object creation. So I'm just going to abstract this rule, because Polar is just declarative code. And I'm going to say an actor who is a user can read any resource if they created that resource. This here is another rule definition, but instead of writing an allow rule, we wrote a create rule. And we can just give this any name we want, just like you would name a function in your Python code, anything you want. And just before I'm running this, I'm noticing I misspelled actor. All right, so let's go ahead and run this again. And it looks like we have a bug in our Polar policy. So we'll see we cannot bind the pattern expense to this variable at line 4. Let's go find line 4. And that's because here we don't have any variable actually named expense. I changed it to resource. All right, there we go. So now we've abstracted the created rule, and we see we get the same result. We'll also see that the SQL is the same. So that's just a quick demonstration of what you can do using OSO and GraphQL. If you want to see more, we have a more thorough example in this repo, which I will quickly check out. That adds another data type to the application, a project, and allows a user to see expenses that are associated with that project. Thanks for watching. If you guys want to discuss this more, we have a Slack channel that we're pretty active in where our engineers will respond to any questions you have about the product. We'd be really excited to chat with you. You can join here. So this is join-slack.osohq.com. If you want to try this out for yourself, the download link and the documentation is available here. And finally, our link to GitHub contains both the example repository that we went through today and the source code for OSO itself. The entire library is open source. And we look forward to hearing from you.